Hello, my name is Catarina Reis. Welcome to the course of Design and Testing of Software. I'm here to guide you through the second topic, testing throughout the software development lifecycle. Let's start with software development lifecycle models. One thing that is quite important to know is that testing does not exist in isolation. So, test activities are related to software development activities. The development process adopted for a project will depend on the project aims and goals and where time to market is of the essence. There are numerous development life cycles that have been developed in order to achieve the required objectives. The lifecycle model that is adopted will have a big impact on the testing that is carried out. It will help to define the what, the where, and the when of our planned testing, regression testing, integration testing, and the testing techniques we will use. Testing must fit in around the life cycle or it will fail to deliver maximum benefit. The V model here presented in the figure integrates testing activities into the whole development process. Here, testing is not seen as a phase that happens at the end of the development. It is recognized that for every stage of the development, a corresponding and equal stage of testing needs to occur. Although variants of the V model exist, usually the V model uses 4 test levels mapped directly to the waterfall development model: component, unit testing, integration testing, system testing, and acceptance testing. It may have more, fewer, or different levels of development and testing. For example, there may be component integration testing after component testing, and system integration testing after system testing. Software work products produced during development are often the basis of testing in one or more test levels: business scenarios or use cases, requirement specifications, design documents, and even code. Both verification and validation can be carried out during the development of the software work products. Verification. Verification stands for, did we build the system right? So, verification helps to ensure that we are building the product in the right way. It checks that the product meets the requirements set out for it. An example of this would be to ensure that a website being built follows the guidelines for making websites usable by as many people as possible. So we can see verification as a confirmation by examination and through the provision of objective evidence that specified requirements have been fulfilled. On the other hand, validation stands for, did we build the right system? Validation helps to ensure that we are building the right product as far as the users are concerned. It ensures that the behavior of the product matches the customer needs as defined for the project. For example, for a website, the guidelines may have been written with people familiar with websites in mind. It may be that this website is also intended for novice users. Validation would include these users checking that they too can use the website easily. Confirmation by examination and through the provision of objective evidence that the requirements for a specific intended use or application have been fulfilled is the ISTQB definition of validation. Iterative incremental development is the process of establishing requirements, designing, building, and testing a system, and this happens in a series of short development cycles. Unlike the V model, iterative life cycles go through a number of shorter, self-contained life cycle phases for the same project. This is cyclical. We go round the development cycle a number of times. The project will have a defined timescale and cost, and within this, the cycles will be defined. For each cycle, a requirement is defined and a version of the code is produced, which will allow testing by the user representatives. At the end of each cycle, a decision is made on what extra functionality needs to be created for the next iteration. Process is repeated until a fully working system has been produced. A key feature of this type of development is the involvement of user representatives in the testing. This approach to software development can pose problems, however. The working environment may be such that developers make any changes required without formally recording it. The amount of testing required to ensure that the implementation of the changes does not cause any other parts of the software is called regression testing. Examples of other development processes that are based on this iterative incremental base include the agile methodologies or yet another well-known models such as the spiral model and the evolutionary prototyping.